Okay, this is lesson 1.5, Advanced Math 1.5. Make sure you have your objective number, and the title is Rational Expressions, which is what we did yesterday, but it's rational expressions with negative exponents. Rational expressions with negative exponents. Okay, simplify. Number 1, a to the negative fourth minus b to the negative second. Okay, before I show you how to properly do it, I want to quickly show you a common mistake that kids make, just so you don't ever try to do it. Kids will say, well, I remember from math 2 and math 1, when you have a negative exponent, you moved it to the bottom. So they do this, 1 over a to the fourth minus b to the second. And that is incorrect. Please do not make that mistake. Yes, they moved to the bottom. If this minus sign had been a multiplication, then you can do this, 1 over a to the fourth times b squared. But if this is a polynomial, meaning there's a minus or a plus sign there, you cannot make one big fraction. You have to make, in this case, 2 individual fractions, like so. Now we're not done because we still need to find a common denominator, but do you see how this became 1 over a to the fourth minus 1 over b squared? And again, that is because there are 2 separate terms, so I have 2 separate fractions. So I cannot do this. Where you could do this if it was like this, a to the negative fourth times b to the negative second, that you could do it this way, and you would be done. That's it. This is not the same as that problem. That's multiplication. This is subtraction. Subtraction, addition. You have to treat them as separate terms. Okay, we are ready to find a common denominator. I'm hoping you recognize that the common denominator is a to the fourth b squared. I'm going to already write it as one fraction, a to the fourth b squared. What is the first fraction missing? B squared, top and bottom. What is the second fraction? A to the fourth, top and bottom. Now you can see that b squared times a to the fourth is the same as this b squared times a to the fourth, which is my common denominator, a to the fourth b squared. All right, b squared times 1 is b squared. Take away a to the fourth times 1 is a to the fourth. And kids will say, yes, I can factor. That's difference of 2 squares. So b plus and b minus. And that's going to be a squared and a squared. I cannot factor any further because this looks like it can, but that's a b, not a b squared. So this is done. Can I reduce anything? No, I cannot. So this is the final answer. And remember what I said in notes the other day. If factoring does not allow you to reduce, it's not necessary. So someone else could have this as their answer and it is still correct. You do this and you're taking the test and the multiple choice answer has this. Should you know they are the same? Yes, kids often think, well, you have to factor and they didn't factor, so it's wrong. Do you notice it doesn't say factor here? We're only factoring to help us reduce. Since it didn't reduce, this is okay. Number 2. C to the negative second minus d to the negative second all over c to the negative 1 plus d to the negative 1. Okay, so do you see I have 4 separate terms, 1, 2, 3, 4, and they all have negative exponents. So again, I'm going to show you the mistake kids make just so you don't try to make it. Kids will say, oh, again, I learned in a previous math class I move things up and down. So that's moving up, that's moving down. So C1 and C2, and then plus D1 and then minus D2. No, it does not work that way. So please do not try to make that mistake. It's going to mess you up come test day. This moving things up and down happened in Math 1 and Math 2. Not sure what you did in Math 3, but when you have separate terms, you can see I have 4 separate terms, which means I will have 4 separate fractions. So it's going to look like this. 1 over c squared minus 1 over d squared in the numerator, and then 1 over c plus 1 over d in the denominator. 1 over c squared, 1 over d squared, 1 over c, 1 over d. Now this looks like yesterday's lesson, the complex fractions, I believe is what it was called. Yes, complex fractions. And that's where you clear, if you remember from yesterday's notes, I told you guys to clear your complex fraction. And I'll just put it up here quickly. You clear your complex fraction by multiplying everything by the common denominator. And that's what we're going to do here. So we multiply top and bottom by the common denominator. And I'm hoping you can see the common denominator is c squared d squared. I'm doing it to the numerator and I'm doing it to the denominator. Now you don't have to make these fractions. I do just to see that it's a fraction times a fraction, but it's not necessary. But I like it because then I can see things that I can see that things cross reduce. C squared is gone, d squared is gone. That leaves me with d squared minus c squared over, and then down here only one of the c's reduced. So this c is gone and this c squared is c. So that gives me cd squared plus one of the d's is gone, this d is gone, this d squared becomes d, which leaves me with c squared d. All right, I'm hoping that made sense. Now, if you remember what I did say yesterday, when you multiply, when you clear your complex fraction, you should have no more complex fraction. It's one basic fraction, no fractions within fractions. Now, it looks like it is factorable, so I'm going to try to factor to see if the factoring helps me reduce. Difference of two squares, GCF. CD times what is CD squared? D, plus CD times what is C squared? D, C, and I'm hoping you recognize that it really truly does reduce. So, if I had not factored, if I said, oh, I don't need to factor here, I'm done, I would end up with a wrong answer because sorry, that's the after school bell, so you can just ignore it. The D plus C's do reduce, and I'm left with D minus C over CD. All right, just a quick side note, just really quick. Some kids would like to factor first, which is totally doable. The method I showed you works. Some kids would say, hey, wait, I can factor that using difference of two squares, which is perfectly fine. Sometimes factoring first doesn't help you, sometimes it does. So we will talk more about this, but I'm just going to show you really quick the other choice. And I know they're both negative ones here because it has to add up to negative 2. C to the negative 1 times C to the negative 1 is C to the negative 2. D to the negative 1 times D to the negative 1 is D to the negative 2. And then C to the negative 1 plus D to the negative 1 stays as is. And then you can cross reduce or reduce this piece and this piece, this piece and this piece. And I'm left with C to the negative 1 minus D to the negative 1, which is now a lot like number 1. Remember, they're two separate terms, so two separate fractions, 1 over c minus 1 over d. The common denominator is CD. I'm hoping you guys can see that. So this first fraction you multiply by d. The second one you multiply by c, because we want CD at the bottom. D times 1 is D. Minus 1 times C is C. Same answer. You choose on these. Some kids like this way better. Some kids like this way better. The more practice we get, you will see some that factoring first is not the best idea. Or where factoring first actually makes it a little easier. We will get more practice. All right, I'm going to move on now to number 3. Two x parentheses x minus 2 raised to the negative 1 minus x squared parentheses x minus 2 raised to the negative 1. Nope, negative 2. All right, I have these two negative exponents here. Recognize you have two terms. First term, second term, which means two separate fractions. First term, second term, which means two separate fractions. Also recognize that this negative 1 is only being applied to the x minus 2, not the 2x. So when I move things, the only thing moving is the x minus 2. And it's now being raised to the positive 1 power. I'm just going to put it like this. And the 2x is staying put. On the second term, same thing. This is the only piece that has a negative exponent, so that's the only piece that's moving. Quantity squared, and the x squared is staying at the top. All right, so we look and we figure out what is the common denominator. And I'm hoping everyone can recognize that it's x minus 2 quantity squared. So this first fraction needs to multiply by what? X minus 2, x minus 2. That gives you the x minus 2 quantity squared. And this one is already taken care of. You don't have to show it, but if you wanted to, you're multiplying by 1. Let's distribute. And I want to distribute here because I want to combine like terms over here later. So 2x times x is 2x squared. 2x times negative 2 is negative 4x. X squared times 1 is minus x squared. And then the x minus 2 quantity squared is already there. All right, and we do indeed have like terms. 2x squared and negative x squared is 1x squared. Take away 4x all over x minus 2 quantity squared. And taking a look, this looks like difference of two squares. X squared minus 4 is difference of two squares. X squared minus 4x is not. But I can factor x minus 4, x squared minus 4x, all over x minus 2 quantity squared. X minus 4 is no longer, it's not a difference of two squares because the squared is gone. X minus 4 is just x minus 4. This is as far as you can go. This is your final answer, which again means since the factoring did not allow me to reduce, this answer would have been perfectly fine. Now, for the only reason I keep going over this, for us in class, I'd like us to get used to doing this because you should always try to factor just in case it reduces. I just remind you about this one here because many times test writers will just write this. Should you know they are the same thing? Yes. All right, number 4. A minus 2 plus, sorry, a to the negative 2 plus b to the negative 1 in parentheses times a to the negative 2 minus b to the negative 1 in parentheses. Okay. You could FOIL. I'm definitely not going to. I'm going to treat them separately. I'm going to clean that one on the left side up. I'm going to clean that one on the right side up. And then I'm going to multiply the two simplified pieces together. Okay, so working here, one big fraction or two separate fractions? Correct, two separate fractions. 1 over a squared plus 1 over b to the first in parentheses. I'm not going to touch that part yet. All right, in order to simplify this, I need to add them. In order to add them, I need a common denominator. And what is the common denominator? A squared b, which means you multiply the first fraction by the b top and bottom, because a squared times b is a squared b, and I multiply this one top and bottom by a squared, because b times a squared is a squared b. All right, b times 1 is b, plus 1 times a squared is a squared. Now, a really quick reminder, because I often have kids get confused with why on these am I multiplying everything by the same thing? C squared d, c squared d, c squared, or d squared, c squared d squared, c squared d squared, versus here I'm only multiplying by a b and an a squared. The difference is here this is a complex fraction. When it's a complex fraction, you clear by multiplying everything by the exact same thing. That allows you to reduce, and end up with a non-complex fraction. This is not a complex fraction. This is just adding two basic fractions, which is something you learned back in elementary school, not with variables, and you learn to add them by finding the common denominator. And common denominators you multiply just by what's needed. This only needs the b, this only needs the a squared, so you're not clearing the complex fraction, you're adding a fraction. All right, this is simplified here. I'm going to work with this one, 1 over a squared minus 1 over b. And then I need to find the common denominator, which again is a squared b. And we're going to multiply by what is missing. This first one is missing the b, because b times a squared is a squared b. The second one is missing the a squared. Again, b times a squared is a squared b. And b times 1 is b, minus 1 times a squared is a squared. And now we're ready to multiply these together. One big fraction. I'm going to write it like this: b plus a squared times b minus a squared. I'm not going to distribute it because I want it in factor form to see if anything reduces. A squared times a squared is a to the fourth. B times b is b squared. And nothing reduces. I can't go any further. This here is the final answer. Okay, that's it for this lesson. Make sure you've made notes, questions to ask me tomorrow in class.